Okay, so we got a physics problem here, and we're going to be doing a chemistry physics crossover. Woohoo! In the Bohr model of the hydrogen atom, an electron with a mass m orbits a proton with a distance of super tiny meters. The proton pulls on the electron with an electric force of super tiny force. How many revolutions per second does the electron make? And let's write down our knowns. So we know mass is 9.1 times 10 to the negative 31 kilograms. Our radius is going to be 5.3 times 10 to the negative 11th meters. And our net force is going to be 8.2 times 10 to the negative 8 newtons. So, since we know the force, we know the mass, we can get the radial acceleration. And radial acceleration is angular acceleration times the radius. And then we can solve for the angular radius, which is in radians per second. Multiply that by 2 pi because the problem wants it in revolutions per second. I think I forgot to copy that over. Yes, I did, but it says to answer it in revolutions per second. So there are 2 pi radians for every 1 revolution, so this will give us radians per second. And let me just do not mass. I know how to write, I swear. Go. So if we extrapolate this out to the just over here somewhere, the square root of FR divided by M with FR being the radial force is going to equal W, and we need to divide W by 2 pi in order to get the radians per second. I'm just going to get rid of this. Not that. Come on. That's the net force. All right, now we just plug it into the calculator. Okay, I input it into my calculator wrong or something. I forgot to put a parenthesis. Oh, wrong tool. This means that it is making 6.56 times 10 to the 15 revolutions a second.